students, today we are going to see some more interesting and important questions from MS Chouhan sir's Organic Chemistry, Isomerism and Level 1 and the question from 181 to 190. Come on, let us discuss these questions. The first question tells about which of the following compound possesses plane of symmetry as well as center of symmetry. They have given the option A, B, C, D in that cyclobutane which is attached with wedge and dash position. We have to identify which is having both plane of symmetry and center of symmetry. It is very simple and easy. Already we have gone through a number of questions. Now we are coming to that end of that session, 190 and 200. There are 20 more questions are there. So let us discuss. So here in this point, here POS, as we check POS, here POS is not available. And the same way here, COS also it's not available. Why? Because this is wedge position and these both are dash position. So in that first compound there is no POS and COS. So both are absent and it's a chiral compound also we can say. Now the next one here dash position and this is wedge position. See, this is wedge and this is dash position. So as we cut over here, POS is present, but whereas COS, when we see that COS is absent. And the same way next one here, as we cut over this side, POS is there actually, and COS, as you observe here, COS totally, because both are wedge, so COS is absent. And this side one is wedge, the other one it is dash. So when we cut over this side, see, when we cut over this side here, POS and COS both will be present. So POS also is present, COS also is present. So as we observe, which is having both plane of symmetry as well as center of symmetry, actually wedge it is upwards and dash it is downwards. So as we cut over the side, so easily we can make out it is plane of symmetry and center of symmetry both are available. So the option D is the correct option. Come on, let us go to the next question to check. The next question, as we observe, which of the following compound has one of the stereoisomers as a meso compound? Meso compound requires, now meso compound requires first and foremost POS, COS. In that any one it has to be present. The second thing, it has to be identical. Identical. See, here POS, COS, any one present only, we can make out some points will be identical. Right now, next one, it has to be symmetry. Symmetry. Right. And optical inactive, so these things should be present for meso compound. Come on, let us check if it is possible in such compounds. Okay, now here as we observe here, actually no chiral center only available, no chiral center. When we are observing this compound here, chiral center is available. So when we cut over here, actually this is POS is present, any one if it is present also, minimum two chiral center it has to be present, so that will be applicable for meso compound. So POS is available and minimum chiral compound, minimum chiral center is available, minimum two chiral center has to be present, yes, that is also applicable. So option B is the correct option. Let us check option C and D. So here actually, here what it is, POS, COS both are absent. So here two are there, but here what it is, here methyl group, ethyl group it is. So POS, COS both are absent. And the next one, it is not an identical position at all, right? Okay, now next one, there is no chiral center. So here you cannot find any chiral center, only two methyl groups are available. So this will not be applicable for meso compound. So for meso compound, minimum two chiral center has to be present, and POS, COS, any one it has to be present, identical symmetry, and that has to be optically inactive. So these are all the points are applicable for meso. So according to these, option B is the correct option. Hope you got the clarity about meso and what are the particulars eligible for being as a meso. I hope you got it. Come on, let's go to the next question. Question, for the following Newman's projection, here they have given this. Actually, dot, it is a front carbon. This dot, it is a front carbon, right? And circle, it is a back carbon, right? So in that way, as we observe in this point here, front carbon ClH2, that is CH2Cl, and back carbon, these two hydrogens are this side and Cl. So that means here one upwards like this, here Cl and here hydrogen, this is front carbon, this is a dot, and back carbon. So in that what it is, upwards, upside down, like upside down and down here. So here hydrogen, here Cl and here hydrogen. So that means this is the way we can observe. So that means this is front carbon and this is back carbon. So ClHH and HCl H. So that means which is the correct option? So this is ClH. This is a front carbon and back carbon hydrogen. Hydrogen here hydrogen and chlorine is available. So this will not be the correct option. Whereas second one here Cl hydrogen front carbon it is fine, but back carbon HCl H. Yes, second option it's correct. Let us check C and D. So this is front carbon hydrogen top it has to be chlorine, but here that is not the correct because top it has to be what it is chlorine, and here bottom two hydrogens are available, right? So here and here, whereas this is totally wrong, and the same way here hydrogen this also. So the option B, as they mentioned, this is front carbon circle, it is a back carbon. So Cl is there on the top, two sideways left and right, hydrogen is there, and the same way back carbon both V shape and down. So V shape hydrogen and chlorine, yes it is hydrogen and chlorine, down hydrogen is available. Hope you got the clarity. Now which is the correct option? Option B is the correct option. Come on, let's go to the next question. Hope you understand that Newman's projection point. The next question, as we observe, which of the following is correct for the given compound? As they have given the options, it possesses center of symmetry, it possesses C4 axis of symmetry, it possesses plane of symmetry, and the compound is chiral. Right now, let us check here. As we observe, three corners, it is actually C double bond O keto group, which is attached with benzene group. Right now, come on, as we observe this center of symmetry, actually center of symmetry, it is not available as we check over here, because here benzene, here actually what it is, C double bond O. So COS is totally absent. And one more thing here, C double bond O, here C double bond O, here C double bond O. So here these are all sp2 hybridization. This is sp2 hybridization. This also sp2 hybridization. But in the center, it is actually sp3 hybridization. You see sp3 hybridization. And COS is absent. POS is present or not? Let us check here. Actually, POS is present. POS actually present. Right. Now, actually, this is achiral compound. Achiral compound. So that means this is a chiral compound. No, it's a achiral compound. When you cut this side, these both are similar. When you cut this side, these both are similar. So it is a achiral compound and it possesses plane of symmetry. Center of symmetry, it is not there. And the C4 axis of symmetry, you know what do you mean by C4 axis of symmetry? When you rotate the molecule, when you rotate 90-degree, it has, you have to get original position. Original position. See, now this is 90-degree. For example, this is 90-degree. When you rotate 90-degree, this C double bond O will come this side, C double bond O. Then that means this will not, you will not get that what it is, original position like this, how we are observing. No, we cannot get that original position. So that means C4 axis also, this also, it's not the correct option. I hope you got the clarity. Now, which is that correct option? The correct option is C. Why? Because it is similar. POS, when you cut, no, these two are similar. When you cut this side, no, these two are similar. So in that way, we can identify what it is. When you cut this side, these both are similar. Like POS is present, COS is absent, and C4 axis, I hope you got the very clear idea about what do you mean by C4 axis. When you rotate that molecule by 90-degree, the around the axis, it looks like identical or original position. So that is called C4 axis. So which is the correct option? The option it is, it possesses plane of symmetry and it is a achiral molecule. It is not a chiral molecule, right? Achiral means it is optically inactive, right? Come on, let's go to the next question. The next question, as we observe, which of the following molecules has axis of symmetry and a coaxial plane of symmetry? See here, axis of symmetry, any imaginary line cuts through that molecule. See, when you cut these molecules, what happened, you know? It is having a bisect and it appears identical. So here, axis of symmetry. Axis of symmetry. Symmetry means here you will get two equal parts. Two equal parts, and what it is, it appears identical, appears identical. So this is called what it is, axis of symmetry. And the same way coaxial axial plane of symmetry, this also the same idea, two equal parts, a similar object, same idea. When you cut the parts, so two equal parts you will get. So that is actually similar parts. These both, when you cut the molecule, right? So two similar parts, that has to be that has to be mirror image. So that is called coaxial plane of symmetry. Okay, now let us check these points whether these are all applicable. So these both the thing you have to cut two equal parts you have to get. So that is where you can identify axis of symmetry, coaxial plane of symmetry. Okay, now here when you cut this molecule, so this side hydrogen and this side hydrogen, yes, that means here POS. Here actually what do we observe here in that plane of symmetry also available, AOS axis of symmetry also available. So POS also it's available, AOS also it's available. AOS it's axis of symmetry, here POS. Right, now next one in this, when you cut this side, so this side also here, both the side when you cut, this is CH, right? So that means here what it is, here also POS is present and AOS is present. Right, now here this is wedge and a dash position, and here Cl and here also Cl. So when you cut over here this side, so this side also, here also the same thing, hydrogen hydrogen. So this side also you can identify wedge and a dash, up and down. So in this also POS is present, AOS also it's present. You got that idea what do you mean by AOS and POS? And right now the next one here, how do we observe in this point, here this side when you cut equally this side benzene and this side, so here also this side benzene and this side. So that means here also POS is present, AOS is present. So all these molecules are having POS as well as AOS. Now this question actually gives why, because no, to confirm and make yourself understand what do you mean by AOS and what do you mean by POS. So which is the correct option? All of these. So option E is the correct option. C, E is the correct option. Come on, let's go to the next question. I hope you got the clarity about the POS and the AOS. When you cut the molecule equally, it is subdivided, and it shows mirror image also. So in that way we can identify POS as well as COS. Come on, AOS, sorry. Come on, let's go to the next question. The next question, as we observe here, number of diastereomers of the given compound. Here, actually, here CH3, CH3, and here also CH3, and here H. Here also, here Cl, here H, Cl, and here H, Cl. Right, diastereomers, it is nothing, a different spatial arrangement. It does not have that mirror image, not mirror images at all. And it actually minimum 2 chiral center, it has to be here. 3 chiral center only it's available. Right, now in that one position let us change. So in that one position let us change means here in this position let us change. So that means here what it is, here CH3, here also CH3, and then here what it is, Cl, H, here the same H, and here Cl, right, Cl, here H, Cl. So this part it has changed. So this part it has changed means other one, next one here the same way we can make it over here, CH3, and here CH3, different spatial arrangements. So that means this is a original molecule, and this one H, Cl, and Cl, H, and then H, Cl, and the same way here CH3, and then here also CH3, and here H, Cl, H, Cl, and ClH. Now you observe all these 3 points here. The first one, it is a diastereomers of this, and this also it's a diastereomers, these both, and the third one also it's a diastereomer. See, one by one it is changing the position, spatial arrangement. So naturally, how many diastereomers are possible? Actually 3 diastereomers are possible. How many chiral centers? In that way we can obtain that diastereomers, changing that what it is, changing actually what it is, each spatial arrangement, so that we can identify that diastereomers. Hope you got the clarity about this. So each one we are changing, each chiral molecule we are changing, and we are finding that what it is, diastereomers. And it does not have mirror image, that is main thing. Cis and trans it is possible, and minimum 2 chiral center it has to be present generally for diastereomers. Come on, let's go to the next question to identify the answer. The next question, as we observe here, and this point also mentions about diastereomers. Which of the structure is or diastereomers of A? So this is a compound A. We have to identify by the pair of diastereomers. So diastereomers, it is like a spatial arrangement. Now, for example, cis means another one trans, R means another one yes. Like that spatial arrangement it has to be. And the next one, it does not have mirror image, non-mirror image, and minimum two chiral center it has to be present. Last point also I mentioned the same thing only. Now here in this point, two chiral center it is available. So here you just check it. So here two chiral center it is available. So one, it is actually according to that RS configuration. Now let us identify that RS configuration. You know very well those rules and regulations and ideas, tricks and all. How do we identify that RS configuration? So this point it is R, this point it is R, and this point it is yes. Okay, now let us check in that which is a diastereomers of A. Now, for example, yes, if it comes means the next point R it has to be. Then R it has comes means the next point yes. So this is the way we can identify diastereomers. Diastereomers. Right. Okay. Hope you got the clarity. Just to the opposite, that means a spatial arrangement, non that is non-mirror image. So these are all the main points to check it. Okay. Now in this point option, this first one here, this is actually yes. And these points and all, how do we find yes and or? I have given a number of times ideas so that easily you can identify in that. So this is yes according to this, and this also is actually what it is yes. So both are yes, yes. So that the other one, second one here and this point. So this is actually yes. The second point, this is yes. And next to this point, so this point, it is R. This point, it is R. So yes and R here, yes and R. So yes and R here, this point actually what it is? Enantiomers. Enantiomers. Right, it is superimposable mirror image. Right, now next one what we are going to check here in this point, this is actually diastereomers because yes and R and yes. So yes, yes, it is coming, it is actually diastereomers, and this is enantiomers. I hope you got that idea about enantiomers and diastereomers. And the next one what it is, this side it is this point it is yes, and next to this point it is R. You please check that rules that you will come to know. So this point yes and this point R, the same yes and R it is same only. This is same identical meso. Right. Okay. Now next one. Here one, two, three, four. Fourth one, what it is? This side it is yes. This side it is yes, and this side also it is yes. Right. So this side yes and this side. Fourth one, yes and yes. This is yes and R. So yes will become R will become yes. So that means this is also spatial arrangement. This point also we can say diastereomers. Right. Diastereomers means one next to that opposite only. So this is yes means here it has to be what it is R. So that R means one has to be same. The other one it has to be different. So one has to be same. Even the first question in that isomerism I have given in the first video. So that is I have given a clear idea about what do you mean by diastereomers. Please watch all those videos so that you will get a complete idea about. Okay, now next one here, fifth one, what it is? Fifth one actually, this side it is yes, and this side it is actually R. This side it's R. So in that way we can identify yes and R. This is enantiomers. This is also enantiomers. Enantiomers. Right, now we are coming to the end of this video. I think I have given all the tips how to identify, tricks to follow that to find out that molecule have given. So that means which are all follows enantiomers. They are asking the question diastereomers. So this is one, it is a diastereomers. Fourth one, it is a diastereomers. So 1 and 4, it's a diastereomers. So 1 and 4, yes, option B is the correct option. I hope you got the clarity. How do we identify? So diastereomers, one will be constant, the other one it will be changing. For example, HCl. This is also HCl means this will be changing ulta. So Cl will come this side and H. One will be constant, the other one will be rotating. So that is the way we can identify the diastereomers. One is constant, the other one it will be rotating. So in that way we can identify the diastereomers. Hope you got the clarity about this question. Now let us go to the next question. As we observe the next question, identify which of the structure below or mesostructure. You know, meso compound, how do we identify? First and foremost, it has to be identical. Minimum two chiral center it has to be present, and a chiral optically inactive, and POS, COS, in that any one also if it is present, we can say this is a meso compound. Right. Now, as we observe according to that, so if we cut over there, so this is POS is present, COS is absent, that is not at all a problem. POS, any one if it is present also, it is a meso. Now, the second one, as we observe here, this is actually what it is, wedge and dash. So wedge and dash, if we cut here, POS is absent and COS also absent. It is a chiral. chiral. So POS, COS, any one present also, it is a chiral. So a chiral means it is identical and meso is present. So in that first one, meso, and the second one chiral. In that chiral, actually you cannot find meso. It is a chiral and it is optically active. This is optically active, but meso, it is optically inactive. Optically inactive. Right. Now next one, in this point, as we cut this side, so this is actually what it is. Meso, both are identical. These both are identical. So this is actually what it is. POS is present. POS, actually it is present. Here POS, actually it is present, right? When we cut two equal parts, POS is present. So it is a chiral. A chiral, it is applicable for meso. That means optically inactive. So these are all the points applicable for meso. Yes. So first one and third one. This is first one and third one are applicable for meso. Now let us check other example also. Here, this one, when we cut this side, fourth one, when we cut this side, actually here opposite side, so here actually POS, COS both are absent. How do we identify POS, COS? Here this and this, actually chiral molecule, this is chiral molecule, you know chiral molecule very well. So how do we identify? So CO is also absent, PO is also absent, whereas here when you cut, you are getting two identical, whereas when you are cutting this side, you are not getting two identical. When you fold, you cannot identify, these both are different, right? So the next one, fifth one. So the fifth one, what it is, when you cut this side, when you cut this side, this is wedge and dash. So these both. So here also POS, COS absent. So this is a chiral. So that means which are the points are applicable for meso? So do you think that you are having a fifth compound is having a chiral? See, this is wedge and dash, and this one, see, double bond, it's totally different. This is actually chiral, optically active only you can identify. So first compound and third compound are applicable for meso. And what are the points to be identified to meso compound? You know very well, a chiral, that means identical, and POS, COS, in that any one it has to be present, and next one optically inactive. So that means a chiral compound, it is applicable for meso. Hope you got the clarity about meso and the diastereomers. Right, come on, let's go to the next question. The next question, how many enol form is possible for this compound? Right, now let me write it for you. CH3, CH2, C double bond O, CH2, CH2, CH3, right, including stereoisomers. See, enol form, it is very simple. Now this is a functional group. As we observe, this is a functional group. In that functional group, next to this points are there, no? So it is alpha hydrogen. Alpha hydrogen, wherever it is there, we can identify the enol form in that way. See, this is very simple way, I'll tell you. So in this, so enol form, it goes this way. So let me write it. How many enol forms are available? Here, CH3, CH, here what it is, that means here double bond C, here O, here H, right? Now CH2, CH2, CH3. Now see this hydrogen, which is getting that hydrogen over here, that is enol. So the double bond comes over here, so that hydrogen shift over there, so you will get that enol compound in this. So this is the enol, right? So this is enol, this is keto form and enol. And the second one, here what it is, I'll give that another color. Here in this point, here second one, here CH3, here CH2, here C, here OH, and the same way here double bond CH, CH2, CH3, right? So that means here you will get that chiral compound. That chiral compound means here C, double bond C, here hydrogen, here CH3, and CH2, OH, in that way. Like, so that means cis and trans, cis and trans. And this side also you will get that cis and trans, cis and trans, where you will find GI, right? Geometrical isomers. So geometrical isomers all are applicable in that stereomers. So here what they are asking that question, including stereoisomers. Stereoisomers is possible, 100% stereoisomers is possible. And cis and trans, two cis and two trans, 1 2 3 4. So how many enol form is possible here? Actually 4. How many enol form is possible here? 4 enol form is possible, right? I hope you got the clarity. This is the correct option. So come on, let's go to the next question. The next question, find the sum of all the stereo centers that are present in below compounds. Right, now let us check chiral center and stereo center so that you will get that idea. Chiral center and stereo center, right? So chiral center means 4 different groups or atoms attached to that carbon, that is called chiral carbon or chiral center. Now A, B, DE. So this is called chiral center on chiral carbon. Whereas stereo center means each chiral carbon is having, now for example, C double bond C, here A and here B and then here D and here E. So this is having a stereo center. In that way, we can identify stereo center. Hope you got the clarity. So stereo center, it's actually a molecule of an atom where the arrangement of its attached groups creates a spatial arrangement. It is called stereo center. Come on, let us find. Now, in this point here, actually GI, it is present. C double bond C. Here, that means here one stereo center, here one stereo center. Yes, it is available for different groups or atoms. So this side CH2, it is there. This side here one more, what it is, stereo center, it is available. So here one and here two and here three. So that means three stereo centers are available in that. Okay, now in that, actually how many in that first compound, it is three. Second compound, here one and here also one, two. That means geometrical isomers. And this side also it is one, and this side also it is one. So in that second compound, four stereo center is available. And the third one, this actually it is same identical groups are attached, whereas here in this point here only one it is available. So that means here only one stereo center it is available. And the same way here also, both are same identical group. So that means here one and here one more. So that means here how many stereo center is available? Here two stereo center is available. So 3 plus 4 plus 1 plus 2. So altogether 7 plus 3, 10 stereo center it's available. I think you got an idea what do you mean by stereo center and chiral center, and how many stereo center is available to check. The same ideas only, but how do we see that arrangement of a group or atom? That is the way we have to check it. See, now here also chiral carbon means chiral carbon, two same groups or atoms attached to that carbon. So that means it is not a chiral, that is a achiral. In that way we can say. So chiral carbon means four different groups or atoms attached to that carbon. That is called chiral carbon in that. Okay, chiral center and chiral carbon, chiral center. I think you got the clarity about all these points. I think we have finished these 10 questions, and hope you understand all these questions. And thank you for watching. Thanks for your great support. In our next video, we are going to complete that isomerism level 1. In our following videos, we would like to show in that aldehydes and ketones, alcohols, those videos also we will watch one below the other. Thank you for watching.